In this video I'm going to highlight some of the basic functions of Logger Pro and also the events with entry data collection mode. In this experiment I'm going to look at how the force applied to a spring affects its extension, and I've got a dual range force sensor here with a spring on the end, and I'm going to stretch the spring by hand and just record its position against the ruler which is next to it. After setting up the hardware, I need to zero the force sensor without the spring on it, so I'm going to click on the 0 up here, and the reading on the force meter down here should drop to 0, about 0. Next thing I need to do is go to the experiment tab, click on data collection and choose events with entry from the drop down. My column name is going to be spring position, and I'll be working out the actual extension later on. The short name, I'm going to call it S, and the units are going to be centimeters. So that's all done, and we can see now the time x-axis has gone. When I'm ready to go, I press collect as normal, but here this new button keep appears and a dot appears on the graph, and that dot changes its position as I pull the spring down, so it's recording the force, and it will only plot a point on the graph when I actually hit the keep button up here. So what I'm going to do is I'm going to pull the spring down, and I'm going to pull it down by maybe 5 centimeter increments, and when I reach the position I want, I'm just going to press keep and it will record the force at that point. So I'm pulling it down to 40 centimeters and I'm going to press keep. It's going to then prompt me for the position, and I'll put in 40. I'm now going to pull it down to 35 and I'm going to press keep and type in 35. Pull it down to 30 and then I'm going to press keep and then type in 30, and so on. So I've just finished collecting my data. I stretched the spring all the way down to 10 centimeters on the ruler, and at this point I need to press stop. So I've collected my first data set, and I'm going to go up to experiment and I'm going to store that run. So I've stored the latest run there, and we can see it's here, run 1 in my data table, and it's ready to take another set of data. So I'm going to go ahead and I'm going to repeat my data collection again using the same positions that I chose in the first experiment. So press collect. I'm going to stretch the spring down to 40 again. I'm going to press keep and put in 40, and I'm going to carry on again, 35, keep, and so on. So I've finished with my second data set, so click on stop and go back to experiment and store the latest run, and you can see that the data was almost exactly the same as the first set. The two graphs are overlapping. And I'm going to go and take my third data set, start collection, and again do exactly the same thing. And that's my final data set. So I'm going to stop collection, and I now have my 3 data sets. My goal in this experiment is to actually plot the average force against the extension of the spring. So I have some processing to do. I have to work out the average force from my 3 trials, and I have to turn the spring position data into extension data. Let's first deal with the average force. So here's my data table here, and what I want to do is I want to add a column that allows me to calculate the average force. So I'm going to go to data. I want to insert a new calculated column. My new calculated column is going to be called average force, and the short name is going to be F will do, units in newtons, and that's fine. But I need to tell the computer how to work out the average force, and we know it's 3 values divided by 3. So the 3 values added together divided by 3. So if I click on the variables, I can choose a specific column, and I want to add the latest force, run 1 force and run 2 force. So we'll start off with the latest force. Okay, there it is. Now I need to add it to choose specific columns, run 1 force, and then plus, run 2 force. Okay, so that will give me the sum of all those forces, but I want to divide by 3, so I better put the whole lot in brackets, otherwise it'll only divide the last one by 3. And then divide by 3, and let's see what happens. Okay, so here we are. This is the average force. It has worked it all out. You can see it's automatically filled the column. So now it's possible, if I go back to the graph, to change this force to average force. And not surprisingly, the graph looks very, very similar. Now, to work out the extension of a spring, I need to know the original position of the bottom of the spring, and you can see on this video here that it's about 40.5 centimeters. So to work out the extension, what I need to do is subtract all my spring position values from 40.5 centimeters. And to do that, I'm going to insert another column, another calculated column to do that. And this is going to be called spring extension. And the symbol can be X for extension, and the unit's going to be centimeters. And the calculation is going to be 40.5, and I need to subtract from that the spring position, and we're done. So let's have a look, stretch that across. There's extension there with the values that look about right. 40.5 minus 40 is 0.5, so that looks good. Next thing I need to do is just change this x-axis from spring position, click it, to spring extension, and the graph's flipped round. Auto scale the graph. I'm going to go to some graph options here to unconnect the points and add point symbols in there. So the graph is looking nice, and I can see my 7 data points. I'm going to add to that a linear trend line. Okay, and there's my linear trend line, and we can see the slope is right there, 0.269 newtons per centimeter. That's the spring constant. That's the force needed to stretch the spring by 1 centimeter, force required per centimeter. There's another bit of analysis I can do as well. I can actually find the area under the graph by clicking on the integral button, and it will shade in the area under the graph. And that's actually the amount of energy required to stretch the spring, because it's the average force multiplied by the spring extension, force times extension. So that's the work done on the spring in Newton centimeters. If I divide that by 100, I get 1.35, and that will then be in Newton meters, which is the equivalent of a joule. So it took 1.35 joules to stretch that spring. That's the energy that's stored in the spring. So in summary, we've seen how to use the events with entry function on Logger Pro, and also seen that in this particular instance the slope of the graph is useful, and the area under the graph is also something useful.